So let's do section A. Let me first get rid of this project. Create a new project. Let's call it section A. Okay, so let's go through these rapidly. A dash is an object-oriented programming concept that provides for objects to be self-contained. Okay, so self-containment and objects, this becomes encapsulation in object-oriented programming. This is encapsulation is an object-oriented programming concept that provides for objects to be self-contained. So to quickly demonstrate encapsulation, we are going to have encaps, a class called encaps. Now this class is going to have a private field called name, and then we are going to have another class called main, and we are going to try to create an encaps object using this line of code like this. So what we want to do is to print out the name like this. So we can't do this. This is causing an error because this name is private. So it is encapsulated from us. We cannot see it outside the encapsulated.java file. But if this was public, then we could access the name like this. And in this case, this would be null, I guess, because we haven't set the name to anything. So it will either bring an null exception or it will just print null. So we have null here because the name is null. So this is encapsulation. Or if there was no modifier and it was still like this, and we tried to run this very method again, it will still print now because let's wait for it to print. So it's still printing now because without the modifier, this becomes package default. So there's package default here. But of course, you don't have to write it. You just have to omit the modifier to make it package default. And to make it encapsulated, then you have to make it private like that. So in that way, the name field, which is private, becomes invisible from any other class outside of encaps.java. So B is dash is a method within a Java class that has the same name as the class, and such a method has no return type. Okay. So a method within a Java class that has the same name as the class is what they call a constructor. So if you have a class like encaps and you create a public constructor with the same name as the class like this, now this becomes our constructor because it has the same name as the class and it returns nothing. Like there's no return type here. It's not void, it's not int, it's not anything. It returns nothing. So that's the constructor. So a constructor is a method. This is a method. This one. It's a method. It's a method because it has those things. So this kind of definition makes it a method. So a constructor is a method within Java that has the same name as the class, and such a method has no return type, which you've seen here. Then C is dash is a Java keyword used to distinguish class variables from instance variables. Aha. Now this is static. So static is a Java keyword used to distinguish class variables from instance variables. So what's a class variable? Let's use this encaps class. A class variable is something that has the static keyword. So we could have static string name like that, and we could set this to Terry like this. And we could have an instance variable called age like that, and we could set this to maybe 12 like that, and it's causing an error. Why? Oh, setting a string and then this is an integer. Okay, so an int like that. So what's the difference between this and this? So we can find out the difference by creating a main method and creating some objects. So object 1 is going to be new encaps like that, and object 1 dot age is going to be like 23, and then I want to set object dot name to something else, something like Salah. Now, how can I show the difference? Okay, let me try. Since we created the object, the first object as that, we can say, okay, let's print out. Let's print out the name for this object, which will be encaps dot name, and then we can create another object and encaps, and then I want to this time I want to set, before I print it out, I want to set the name to Salah like this. So when I print out the name, it should print out Salah. So what happens if I have a third object? Obj3 is equal to new encaps. What happens if I print out encar.name like this? So initially we have a static variable called Terry, a static variable called name with the value Terry, and then in our main method we are creating an object and printing out this name And then here we are creating a second object and setting the name to Salah and printing it out. And also here we are having the third object and printing out the name. So what we are going to see is, at first here, when we are printing out the name, it's going to be Terry. Then in this second object, we are setting this static variable to the value Salah. So when we print it out again, it will have the value of Salah. Same here, when we print out the name again, it will hold the value of Salah, not Terry. Because let me first run it. So we are going to see Terry, then Salah, then Salah. So Terry, Salah, and Salah. Why? Because in Java, once you make a variable static, it is stored in memory at only or in only one place. So you'll have like one place in memory that holds the string value Terry. Imagine this is your memory somewhere. So it's only going to be held in one place called, and that one place will hold the value Terry. So when we come here and set this place here to something else, it will get rid of this value and replace it with Salah. So every time we reference this static variable called name, it will point to this value here, which is Salah. So how is this different from this edge field? So for the edge field, we can do something like this: edge dot no obj1 dot edge, and this is obj2 dot edge, and in this case we are going to set the edge to 32 and try to access it here, obj2 dot edge, and this is going to be obj3 dot edge. Now in this case, what we are doing is, after creating this first object, we are accessing the edge field, which is this one. Initially it is set to 12, and then we are creating the second object and we are setting this field again using the second object. We are setting the field to 32. So here what we shall see is 32. Here we shall see 12, and here we shall see 32. So what happens when we create a third object and we try to access the field property here? What we shall see here is 12 again, because we are looking at this initial field here, which was set to 12. Remember, for static fields, when this field here, when this static field here was changed, it was changed permanently. So any other, it didn't matter which other object tried to reference it, it would still print out the changed value, which was Salah in the previous example. But in this case, to demonstrate this one, we shall access it first and print out 12, and then we shall try to change it again to 32, and we shall print out 32 because we've changed the value to 32 here. So this will give us 32. But what happens when we create another object and try to access the same field here? We should not get 32. We should get what? 12, because this value is not static. It keeps on changing depending on what the object is doing with it. So if we run this, we should get 12, 32, and 12. So we get 12 because the first time here we are accessing the first what value, which was set to age, which was 12. But when you come here to encaps this second object, what the second object is doing, it is setting this field value here, this field here, this one. It is setting it to 32, but only for this object. So when you try to print it out like this, but we try to print out the value of age, we get what? 32, because it was set to 32. But it is only for what? For this object 2. Because when we came here to object 3, to the third object, and we tried to access, we didn't do anything with the age, we just tried to access it. So why didn't we get 32? Because it was, the last change was what? Was 32. So why didn't we get 32? We didn't get 32 because this value here is not static. When we reference the age field using another object, it will reference this one here, this value here. So we shall get 12. And in this case we got what? We got 12 here. So what happens if this value was also what? Static, like this. What will happen is, at first we shall access it and get 12 because the initial value was 12. Here, we shall get 12. Then we shall access it here again and set the value to what? 32. So when we print it out here, it will be what? 32. And then in the third object, when we try to access it again like this, it won't give us 12 like last time. It will give us the last what? The last modified change, which will be what? 32. So we shall get 12, 32, and 32. Because in memory, it's no longer what? It's no longer 12. It now becomes 32 because of this change here. So in Java, when something is static, like there's only one place in memory where it resides. So when you change that one place in memory, it will change for all what? All occurrences in that code. So when we run this, we should get 12, 32, and 32. Just like you can see here. That's what they call a property of the class. So this static property, it belongs to the class. It does not belong to the instances of this class. It belongs to the class. So there's only one copy of it. So there's only one place in memory where this value is stored, as long as it is what? It is static. So that's what this here means. Static is a Java keyword used to distinguish class variables from instance variables. Without the static keyword, this becomes an instance variable, like this. So this here becomes an instance variable. But once you include the static keyword, then it becomes a class variable. So it's part of the class, and it only has its value is only stored in one place in memory. So that's the difference. Then we have part D. D is the only class in Java that has no superclass. So this is object. Object is the only class in Java that has no superclass. So all classes derive from objects. Like all classes extend the object class like this. But this is implicit, so Java already implicitly does this, so you don't have to do it every time you create a new class. But all classes extend the object class, so the object class is the superclass of all other objects. This guy here. So as you can see here in the Java docs, it is saying class object is the root of the class hierarchy. So everything starts from here, and then any other classes below object. So what else? Part E. Dash is the ability of an object in Java to appear in different forms based on the environment it is in. So this is the ability to appear in different forms is polymorphism. So if we try to demonstrate this, with code, we could have something like a class called poly, and this class is going to have public void method called poly, and I am poly. So we're going to have another class down here called poly B that extends the poly class, and we are going to override the poly method, public void poly. So we have the same thing, the same method here, which in this case is poly, this same method here, but it is going to behave differently depending on where it is used. So this is poly has no name. So if we have the main method here and we try to create objects of type poly B, new poly B. So we have poly B dot poly. So in this block of code here, poly B, this method here, this method call is going to refer to this overriding method here. So it will print out poly has no name. Poly has no name is what is being printed out. But if we don't override this method, we are going to see a different output for this method call. So if we run this, we are going to see I am poly. So we have the same thing behaving differently. This is what polymorphism. So at first we can make it print out poly has no name, like this, or we can choose to make it print out what I am poly by not overriding the method, like this. Like that. So we have one method call behaving differently, and that is polymorphism. Okay, so part F. Dash is the ability of a Java class to take on properties and behaviors of another related class. This is inheritance, and we've tried this with polymorphism as well. So the ability of a Java class to take on properties and behaviors. Properties are the fields, behaviors are the methods of another related class. So here we've seen this class here, and we have used inheritance here to extend the poly class. So by doing this, we are inheriting the behaviors within the poly class, and behaviors are what? Are methods. So this method here, or this behavior here, is being inherited by this class here, because when we, in the main method, when we create an object of this type, like we've done here, and we call the poly method, this compiles fine. It does not cause an error. Why? Because by inheriting this class, it comes with what? With this method. So in a way, it's like this method is also defined inside here. But this is how you should say it, because when you inherit, you're kind of you're taking on the behaviors of that class as well. So by inheriting this superclass here, you also have access to what? To this method. That's why by calling poly, we are calling this very method here. That's why this can run. So that's inheritance. By inheriting this, we get access to that. Because when we get rid of this, then we should get an error here, because it won't know what poly is. It will be like, I don't know what this is. I cannot resolve this method. Where is it? I don't know where it is. So it is to bring it back, you must then extend the class, which comes with what? With that behavior. So that's inheritance. The ability of a Java class, this Java class here, to take on properties and behaviors of another class. So we are taking on this behavior here. So yeah, like we've done here. That's inheritance. Then G is in object-oriented programming. Dash are used to model the behaviors of objects of a class. We've already said behaviors are the methods. So methods are used to model the behaviors of the class. Like we've done here with this. These are the methods which model the behaviors of a class. We model behaviors of a class by declaring and defining methods within that class. H is when using scanner class from java.util package, dash is the default input stream that the scanner object uses to read user input from the keyboard. So when you're using in a main method, let me create a new class. Scan. So in a main method, when you're doing this, when you're creating a scanner, the default input stream for a scanner is what? System.in. System.in. This is the default input stream. Like you're going to be inputting something for the machine to read. So you're going to be scanning the what? The keyboard for input. That's why the default input stream here is going to be what? System in, because when you're printing out something, the default output stream is what? System.out, because you want to display something on the screen. So display something. You display something with system.out. So the default output stream for Java is system.out for outputting something onto the screen. But when you want to read something from the user, then the default input stream is what? System.in, because you're inputting something into the system. So if you run this, we should get an output here, because we are outputting display something. That's the default output stream, this one, system.out. The default input stream is system.in when you're picking stuff from the keyboard. And I is during method overloading. Dash is a term used to uniquely identify each of the versions of the method that has been overloaded. Okay, so let's demonstrate method overloading quickly. Overloading. So let's create a bunch of methods: public, void, add, public. So that's one method. So to overload this method, I have to change the signature here. So to overload the method, it must have the same name, but the parameters have to be different. So that is me overloading this method. We have the same name, but the parameters are what? Are different. So you can overload it with how many parameters, whichever parameters you want. But these parameters have to be what? Different. So it's not that it should be one parameter. You can have still one parameter, but that parameter is what? Is of a different type. Like this. This is still method what? Overloading. So you have one parameter here and one parameter here, but the parameters are of what? Different type. So you have an integer here and a string here. This is still method overloading. So method overloading is where you have one method but different what? Signatures. Different parameters here. Here you have nothing, here you have an integer, here you have a string. That's method overloading. So we do that by changing the signature. J is dash is a Java keyword put after the visibility modifier to indicate that the class cannot have a subclass. Okay. So if you don't want your class to have a subclass, then you must make that class what? Final. So after the visibility modifier, we have to say final. So this class here is final, which means if I have another class down here, I cannot extend the final class. This won't be possible. Because here it's saying you cannot inherit from a final class. So if you don't want your class to have subclasses, then make it what? Make it final. Which was the answer here. Final is a Java keyword put after the visibility modifier. To indicate that the class, this class here, final class, cannot have a subclass. So it cannot have another class which extends it. It cannot have a subclass. Okay, that's I. K is dash is a Java keyword used to indicate that a method should not be overridden by the subclasses, even if it is visible in those classes. Is a Java keyword used to indicate that a method should not be overridden. Let's go to the poly one. So if you don't want this method to be overridden, then we have to make it what? Final. When we make it final and a class extends this class here, we cannot do, this won't be allowed. We cannot override that final method. Because without the final keyword, the overriding is possible. You can override it here like this. But once you include the final keyword, then you cannot override the method. So here the answer is final, is a Java keyword used to indicate that a method should not be overridden. static final makes no difference. The keyword required is what? Is actually final, because final prevents methods from being overridden. But it can also be static, so you can either use static or you can use final, because a static method can also be what? You cannot override a what? A static method. So method does not override method from its superclass. Once you have a static method, what is this called? Is it called static binding? Oh, not sure. But basically, you cannot override a static method, even though here it looks like we have overridden it. So let's first get rid of this annotation, and yeah, still the same. So instance method poly in this class poly B cannot override a static method. So you cannot override static methods. So in this case, the answer was either static or final. Both could have done the job. So static or final, you cannot override. Then there's this extra bit of information, even if it is visible in those classes. So even if it is visible in those classes means even if here it's public or private, because since here we are in the same file, if we make this private, it won't make a difference, because private methods and fields can be accessed within the same file. So regardless of the visibility here, if it's static and final, it cannot be overridden. Rather, if it is static or final, it cannot be overridden. What happens if it is static and final? What is this? Static method declared final. You can't have static final. So okay. So you can't have static and final in the same declaration. Okay. So it's either static or final. Okay. Okay, so that's the one. Let's do part 2. Part 2 is saying, copy and complete the table below as far as visibility modifiers in Java are concerned by putting a tick where visibility is possible and an X where visibility is not possible. Okay. So I didn't have a table for this. Let me just try to demonstrate it with code. So on this column we have the visibility modifiers, and these other columns are where we are supposed to put a tick or not. So private, accessible within that class where it is defined. This is true because let's create this called visibility. So we are going to have a private method, private void method, and this method can be accessed. Visibility. So we can access this method like this. Even though it's private, we can still access it because it is defined within the same what? The same class. Accessible, protected. This is also true. This is supposed to be a tick because even if this is protected like this, you can still access it like this within the same class. Then default is also true because to make something default, you just have to remove the modifier like this and make it package default. And here you can still see, you can still access the method because it's all in the same what? In the same class. So here it's tick, tick, and tick. So what happens when we go to a subclass? So if we go to a subclass and let's create a subclass here, subclass which extends visibility. So in this subclass, subclass equals new subclass, can we access the method? Yes, we can. Because it is package default in this case, but we are dealing with private, so let's make it private. And once it is private, and we try to access it in the subclass here, you can see we get an error because we cannot access a method with private visibility if we are in a what? In a subclass. So this becomes an X. This is an X here. So what if a method is protected? That should be true. We should be able to access it. So once you make it protected, then you can access the method in a subclass. And what happens if it is default, package default? If everything is in the same package, this should also be a tick. So we should be able to access this method. So by removing the visibility modifier, we make the visibility package default. And as you can see, this doesn't cause an error, so we can access the method still. So this is a tick and a tick for protected, but a cross for private, because as we saw earlier, private methods cannot be accessed in a subclass. Then for this column, accessible in another class in the same package. Okay, so let's create another class. Let's call it another class. Let's give it a main method, and another class. Another is equal to new another, and we want to try to access the method in another class in the same package. Okay, so we are in the same package here, and if we try to access, this is the private method, like this. So this is impossible. We cannot do it. Because this method here is private, so we can't access it from another class, even though we are in the same package. So what happens if this method is protected? Here, so this is X, we cannot access it. So what happens if it's protected? If it's protected, then we should also not be able to access it. Protected. I have a feeling we should be able to access it, but let's see. So once we protect the method, then we still can't access the method unless we extend it. Visibility like this, then we can access the method. And okay, what if it was package default like this? Then we still cannot access the methods. But we've been doing all this without extending. So what happens if we extend visibility and make it package default, right here? We should be able to see it. Visibility. here you should be able to see it, and just like you should be able to see it if it's protected, you can still see it if it's protected, as long as we are a subclass, and we are extending visibility. So what happens if it's private? This should not be possible. So here we cannot able to see it. But is this for methods or for fields? Okay, so accessible in another class in the same package. So here, this should be X. This should also be X. This should also be X. Because there's nothing like inheriting here. We are just trying to access from another class without what? Without inheriting. So everything is not possible, either with private, as you can see, or with protected. That is also not possible, or with package default, like this. It is also not possible. So if there's no inheritance, you cannot do anything with these methods or fields that are that have this kind of visibility. So this would be X, X, and X. And so let's do part 2, rather part 3. Using an example of your choice, use Java programs to demonstrate each of the following object-oriented programming concepts. No mark shall be awarded for any explanation or definition given in this question. Only the code is required, and you must number your work properly by clearly indicating the concept you are demonstrating at the top of the program. Okay. So I'm going to demonstrate all these 3 concepts. First is constructor overloading. Make use of the overloaded constructors. Okay, 6 marks. So let's do some constructor overloading. Constructor overloading. Let's demonstrate this. So what I'm going to do is I'm going to have a field called name, like that, and then I'm going to create a constructor. Let's create public constructor overloading like this. So string name like that, and then this, I'm going to use this keyword to refer to this field here. So this dot name, this field here, this name is equal to this name, like this. And then I'm going to overload this constructor here. Remember what I said about overloading? Overloading is when you have the same name but a different what? Different parameter here. So we can have something like this. So this is constructor overloading. And in this case, our name, this name here, I'm going to set it to John, like this. So they want us to make use of these these overloaded constructors. We have 2 overloaded constructors. We have this one, and we have this one. So if I create a main method down here, and I try to instantiate my constructor here, instantiate my class using this, I'm going to use the first constructor overloading. Okay, so it's not allowing me to use this overloaded constructor. Oh, I'm forgetting the new keyword. Okay, so there we go. Okay, so we have this first object. So let's print out the name using the first object like that, and also create another. I chose a very long name for our constructor, but let me try to shorten it using CO. So control CO like this. So then we need to change this to CO like that. So CO2 is equal to new CO, but this time I want to make use of what? Of this constructor here. So I want it to take the name Terry like that. So if I try to print out CO2 the name, I should get what? Terry. But in this first constructor here, we used this one here. And when we use this constructor, it set the name to what? To John. So here we should get John, and here we should get what? Terry. So if we run this main method, okay, we're getting errors from our previous guys. So let's make sure we have no errors to. Okay, get rid of that. Okay, so if we go back to this and run, it should give us John in this case, because this constructor is setting the name to John. So we are getting what? John here when we try to access the field. And this second one is using this constructor here, which is using this guy here. Let's move to right stop. So we have this going on. So our first constructor is using this constructor here, which is setting the name to John. So we are getting John here. And this second constructor is letting us set our own name here. So whatever we put here will be this one here, which will be transferred to this name, and this name is pointing to this guy here. So when we try to access this field like this, we are accessing what? We are accessing this field up here. And in our first constructor, this field here is being set to John. That's why you're getting John here using this code. And in the second one, this field here, this one here, is this one, which is being set to whatever we put in this argument here. And in our case, we put what? We put Terry. So that's why you're getting Terry printed out on the console like that. So that's constructor overloading. We have overloaded two constructors like that. Okay, so let's do method overriding. You do not have to call any method. Okay. Method overriding. Method overriding. Let's do override. Method overriding. So let's have a method called one like that, and this method prints out one like that. So method overriding, this method overriding here only happens if there is what? Inheritance involved. So we need to inherit some overridden. I'm going to create a class called overridden, which will extend overrides, and then we can then override this one method like this using this annotation like that. Oh, wait. it's complaining. Why? Oh, that's wrong. That's wrong. And override methods. So, what's going on? Is it because we didn't include public? Okay, what is happening? Hmm? I'm not understanding this error. Annotation type expected. Annotation type. Okay, let's try to let IntelliJ do it for us. So I want to override this. Why is it forcing us to use this? I do not know why. But when I get rid of it, it contains. Don't know. Because when we try that in poly, like we could easily override this guy. That it being fine. Oh, that happened. Don't know what has happened. Something has happened. What happens if we have different classes? No. Annotation type expected. I don't know what I've done. But this is supposed to not cause an error. Okay, let's undo the move. And undo this as well. Okay, let's stick to it because even though we removed it, it will still not complain. I think it's something to do. I don't even know what it's to do with. So basically, what I want to do is I want to, instead of printing this guy, I want to print overridden one like that. So this is causing no errors. They said we don't have to call any method, so just by doing this, we should get our max. But what happens if we, let's just call overridden. Let's just call the method one. So this should give us this overridden one as the output, because we are overriding this one here. And if we call, let's create an object of type override and try to call that method override. So if we call the one, we are calling one here and we are calling one here. This one should print the overridden one, and this one should print this one. So running that, we should get overridden 1 and 1, as you can see. But we don't need this to be written. So that's what the question asked for. This one is bugging me. I don't know why we cannot do this anymore. But anyway, since we are not interested in annotations, we don't have to debug that. So let's move to recursion. Method recursion. Your program should make a call to the recursive method and provide some output. Capturing user input at runtime is not necessary. Okay. So we don't have to use the scanner, we just have to demonstrate recursion. Okay. Recursion. Okay, let's demonstrate recursion. So what's recursion? Recursion means calling a method recall. So you're recalling a method or recalling the same method. Okay, let's try to demonstrate this. So in our main method, I am going to, before we do the main method, I am going to create a class, not a class, a method called let's try add. And this method is going to call itself like this. So as you see, IntelliJ is saying this has become a what? A recursive call. So it's like we are going to have this method, but it's going to call itself, because when you call it like this, it's going to still execute this block of code. So if we output calling add like this, and in our main method down here, we create a recursion object, new recursion, and we try to call the add method like that. So what this is going to do is it is going to print out this, and then it is going to call the same method, this same method. It's going to call itself again. So when it calls itself, it's going to print this out again and then call itself again. So basically you're going to have an infinite loop happening here. So you see an infinite loop here. It's going to be calling itself infinitely until the program crashes. So if we do this, we should get calling add until we cannot call add anymore. So we've been calling add until our program crashed. As you saw earlier, it printed out this and then it crashed. So to avoid the crashing, we could maybe do some control and say if, let's call it 10 times, if I is less than 10, return. And let's set I to 0. And let's have I how should I do this? have I0. Okay, let's put the recursive call here. So I0, then call the thing. No. This will get rid. This won't run. This code will become dead. So let's go back to how it was. And here we are not incrementing I. So this is always true. So what if we incremented I like this? That will still be true. Okay, let's try it like this. Let's say if I is less than 10, do the recursive call. And then no. Okay, let's increment I from here. I plus plus. No, it's not. This is always true. Okay. Because okay, I see why. Because every time we call the add, we set what? We set I to 0. So every time we are calling, I is 0. So it won't even increment. So let's cut this and put it. No, even this one won't do. So let's make it a static field and set it to 0, like that. Remember, a static field is referenced in memory somewhere. Okay? It's referenced or it is stored only in one place in memory. So when the program starts, it is set to 0, and here we are going to print this out. When we call the add function, we are going to print this out. Then if 0 is less than 10, increment it. Remember, it is static, and static values can be incremented. So we are going to increment it to 2, and then call the method again. So when we call the method again, it's going to print this, and then check if 2 is less than 10, which is true, and then increment it again to 3, like that. So it's going to, this will work for us. So at first it is 0. So if we try to run this again, it should print out calling add 10 times and then quit. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Why is it 11 times? Well, I guess it's because, oh yeah, because we are beginning from 0. So it's going to print out let's do something like with I equal to. So we actually see what I is when the method is being called. So okay, yeah. So what is happening is when I is 0, this is being printed, and then it does the check. So remember when I is 9, when I is 9, 9 is less than what? Than 10, which is true. So when that happens, I then becomes what? 10 from 9. Here it is 9. And here it becomes what? It becomes 10. And remember, we are yeah, so after this happening, we can then call the add again, and then it will print calling add with I being what? Being 10. So when it does the check here again, 10 is less than 10, which is false. So this never runs again. This here never runs again. So, but why are we having 11 what? 11 calling adds? It's because we are starting from 0. So we have 0, 1, 2, 3, all the way to I being what? Being 10. Yeah, so we could maybe print out this only when we do this check like this. Then we can have, we should only have what? 10. Sorry. We should only have 10 calling adds. So when we run this, only when the condition is met is when we should get what? When we should get the message printed out, this one. So we have 0 all the way to when I is what? I is 9. So when I is 9, then we print this out. And the next time we call add, I will have been 10, and this condition will be false, so we can't do anything but exit the what? Exit the method. So that is recursion. Recursion is basically recalling the same method every time, as we have done here. We are recursively calling this method. So that is recursion demonstrated. And yep, that's all. That's all about part 3 and section A as well.